ठीक है भैया, at the end of the class, ठीक है। अच्छा चलो ये स्टार्ट करते हैं। वी विल स्टार्ट विद एक सेकंड में देख लूं which one. Just give me 1 second. So this one, latest questions that he can reaction kinetics. So starting with the first one, somebody should have a calculator with you. ठीक है? Use the graph to. Achha, now in this question, he's saying the first part that he's saying is that the rate of the reaction between 2-chloro-2-methyl propane and methanol is investigated when a large excess of methanol is used. The overall reaction is first order. So the overall reaction, use the for determine the reaction in 40 seconds, show all your workings. Achha, first thing, when you use a large excess of methanol, so that basically means that you're keeping methanol's concentration constant. So when he says that the order of reaction or the overall reaction is first order when a large excess of methanol is used, that basically means the order is for this chloroalkane only. इसके लिए होगा only for the chloroalkane because methanol is being kept constant. But anyways, first thing, 40 seconds, you need to figure out the rate of the reaction. So how would you find the rate of the reaction? You're going to draw a gradient at 40 seconds. So 40 is going to be what? They didn't even give you any points for 40. So approximately it's going to be a gradient at this point. I'm just going to mark a rough gradient. I don't have a ruler, okay, so rough gradient at 40 seconds. And we're going to try and measure the gradient quickly. So difference in y, so that's y2 minus y1, so it's I think 0.0150 minus 0 divided by what's the difference in x. That's around, let's say, what is this? This is, make this 80. Okay, so let's say this is 80. What is the value that we're getting? Can somebody calculate this quickly? So you're getting 1.875 times 10 to the power minus 4.
So can we do with half-life, like if it says the first order?
You can't at 40 seconds.
Like actually, it says the first order.
It is first order, but how would you use the half-life? I mean, you can actually do that. Rate is what? It's 0.693, and let me just double check the constant. 0.693. 1 second. Let me just double check the constant. 1 second. 0.69. That's k is equal to 0. Not rate. K is equal to 0.693. That's the rate constant. You can't use the half-life. At least not in this case. Okay, Dipesh, is this clear? You would have to draw the gradient, and you would have to show the gradient, and all the working has to be shown.
Half-life is for the rate constant, right, sir?
That's for the rate constant. K is equal to 0.693.
So this is a rate reaction.
T half-life, right? Next one, use the graph to show that the overall reaction is first order. Explain your answer. So how is the overall reaction? Now, first order, what is the half-life for a first order reaction? If it's a first order reaction, the half-life is going to be constant, right? तो यहाँ पे the half-life should appear to be constant. So the first half-life is, I think, this one. The second time the concentration decreases by half, it's approximately the same. जिसके अंदर आपने क्या करना है कि the half-life is constant. ठीक है, for this one, show that the overall reaction is first order. The half-life turns out to be, it turns out to be a constant value. So that's why, and you have to give the values over there for the half-life. Yeah, at least show the working on the graph. Next part is in a different reaction, which is also first order reaction. 75% of the reactant is consumed in the 20 seconds. Calculate the rate constant K for this reaction, state the units of K. As a first thing, can somebody tell me how would you measure the half-life? He says that 75% of the reactant is consumed in 20 seconds. 75%, and it's a first order reaction. Can anyone tell me what the half-life is? In how many half-lives is 75% of the reactant consumed? Like, let's say you start off with 100%. Not three, no, not three. Let's say you start off with 100%.
2 half-lives.
Two half-lives over. If you start off with 100%, right? So after the first half-life, you'll be left with 50%, right? So that's the first half-life. After the second half-life, the 50%, its concentration would further decrease by half. So it's going to become 25%. So that's your second half-life. So that's basically two half-lives. After two half-lives, your concentration has decreased by 75%. So this is 320 seconds is basically equal to two half-lives. Clear path? And based on that, since half-lives are constant for a first order reaction, bring this 2 over here, it's going to become 160 seconds. So T half is going to become 160 seconds. So you figured out your half-life. And now you can figure out the rate constant using that, which is K is equal to 0.693 divided by T half, which is 160 seconds. क्या value आती है इसकी?
(4.3 into 10 to the power minus 3). 4.3.
4.3 or S minus 1, right? Formula से ना you were able to figure this out by just looking at the formula. You could have, for a first order reaction, remember it's always S minus 1, because even if you K is the reactant concentration order 1, right? So it's mole per dm cube per second. S minus 1, K is equal to mole per dm cube. So the mole per dm cube gets cancelled out. So formula said that you were able to directly figure out that it was going to be S minus 1. The next part. As the next one is, we've got now the next question, what's a homogeneous catalyst that the reactant and catalyst are in the same state or phase? What's a homogeneous catalyst? They are going to be in different states. This particular reaction, he's saying, I mean, this one, the iodine and S2O8 reaction, you have to remember this particular example for a homogeneous catalyst. Okay? So he's asking you to write the two equations to explain how Fe2 plus acts as a catalyst in this reaction. Okay? This one example you have to remember remember all of this. So I'm just going to go over all of this. So what happened was that you had an iodine electrode, you had a S2O8 2 minus electrode, and it was forming 2SO4 minus 2. So the iodine one was 0.54 volts. The S2O8 was 2.01 volts. And they would not react together, even though the reaction was feasible. The lower potential lost electrons, the higher potential ended up gaining electrons. But the reaction was not feasible because your both reactant ions were negatively charged, which resulted in a very high activation energy. Negative ions, they repel each other. So to prevent, because the two negative ions were always repelling each other, so to speed up the reaction, you would add iron ions as catalyst. And these iron ions had an in-between potential. The potential was somewhere in between. So what would happen with iron ions is that if they were to react with iodine, they were the higher potential. So they were the ones that would gain electrons. And the other one, the iodine lost electrons. Iron reacted with iodine. Iodine was the higher potential, so it gained electrons. Iodine was the lower potential, lost electrons. So you can write an equation for this that it's so this one was Fe3 plus. You have to balance the number of electrons as well, so it's going to be 2 Fe3 plus reacting with 2I minus 1, and the product of the reaction was 2 Fe2 plus and iodine. ये आपका products are for, if you add iron ions, the iron ions would go and react with iodine. But at the same time, the iron ions would also react with the S2O8 ions as well. With S2O8, it was the lower potential. So the lower potential lost electrons, and the S2O8 ones, they gained electrons. So S2O8 would gain electrons, and the Fe2 plus would lose electrons. And they would turn into 2 Fe3 plus and 2SO4 minus 2 would be formed. So afterwards, you had these two reactors. Now, you have to remember the whole process. Since they were using Fe2 plus as a catalyst, so I think you should write the second equation as the first equation, and the equation over here as the second equation, TK, because you're starting off with Fe2 plus. So just 1 second. So remember this example. This specific example of homogeneous catalyst, and suggest why the alternative route in the presence of Fe2 plus ions have a lower activation energy than the route in the absence of a catalyst. So this is where you're going to mention that directly they were not going to react because I minus 1 and S2O8 were negatively charged. So they had repulsion. I minus 1 and S2O8 ions without the iron ions in between, they were not going to react together because they were negative ions and they would repel. So the iron ions as an intermediate, they were added. The iron ions would react with I minus 1, turn them into I2. The iron ions would also react with S2O8 and turn them into SO4 minus 2. So you got both of your products. And why was that reaction faster? Because now with the presence of iron ions, the two ions in the equation are oppositely charged. So the alternative route has opposite charged ions. So there is no repulsion, which leads to a faster reaction or a lower activation energy. Is this clear, this part? You clear it?
Yes, sir.
I said, again, remember this. Okay, now you don't have a data booklet, so you have to remember these equations by heart. Okay, there won't be a data booklet for you to help you out in this. As a next part, okay. Now in the next part, you have this nitrogen monoxide. The reaction is second order with respect to nitrogen monoxide. So this is order number 2, and the other one is first order with respect to O2. Under certain conditions, the volume or value of the rate constant K is this. Construct the rate equation for this reaction. So rate equation is K is K. Rate depends on both reactants. So it's NO concentration, and that's going to be squared, and O2 concentration, and that's order 1. And he's asking you to calculate the initial rate of the reaction under these conditions when the initial concentration. So you just have to use this equation now. You have to find the rate. The value of the constant is known. That's given over here. That's 8.6 into 10 to the power 6. Into NO concentration, which is also given over here. That's 7.2 times 10 to the power minus 4. And that's squared. Or O2 concentration, that's 1.90 times 10 to the power minus 3. This key value, Nicolo, what are you getting for this? Yeah, किसने calculate?
8.47 into 10 to the power minus 3.
Minus 3. Okay. As a next part, that's as it says a continuation. Now he says there's a drug cisplatin hydrolyzes in water, so it reacts with water. The rate of the equation is shown. So that means there were two reactants. You had water and you had this cisplatin. So the rate only depended on one of them. Okay, not on water. Water has an order of 0. If it's not appearing in the equation, its order is 0. So the value of K is 2.5 times 10 to the power minus 5. The reaction has a constant half-life. Explain why this is the case. Because the order with respect to its first order, right? Overall order is for the reaction. Now use the information in the question to show that the half-life of this reaction is 2.77. The formula here, that's K is equal to 0.693 divided by T half, right? So we need to find T half, which is going to be what? It's going to be, so the half-life will be 0.693 divided by the rate constant K, which is given somewhere. This is given over here. That's 2.5 times 10 to the power minus 5. So, are you getting the same number?
Sir, is it 27720?
वो यही हो गया ना ये वाला, right?
Yeah.
So next one is there's 8 into 10 to the power minus 6 moles of cisplatin are added to 100 cm cube of water. Calculate the time taken for the concentration to fall to 2.5 times 10 to the power minus 6. As a first thing, what is the concentration initially? Kya concentration? How do you find concentration? Concentration is moles over volume. So it's 8 times 10 to the power minus 6 divided by what's 100 cm cube and dm cube. That's 10 to the power minus 1, right? So 0.1 is 10 to the power minus 1, right? So it's going to be 8 times 10 to the power minus 5, right? Mole per dm cube. So you're getting 8 times 10 to the power minus 5 mole. That's your initial concentration. That's your concentration right at the beginning. So now what we have is, he says how much time would be taken for the concentration to decrease to 2.5 times 10 power minus 6? So now there are two ways of doing this. You just try and figure out how many half-lives is this. Okay? Divide this by 2. मतलब या तो by trial and error कर लो, ठीक है? By just doing this repeatedly. First half-life, ठीक है? It's order 1. First half-life, the concentration would decrease by half. So the first half-life, the concentration should come out to be 4 times 10 power minus 5, right? Hey, Kaga, what's the second half-life? The concentration would decrease by a further half. So it's going to become 2 times 10 power minus 5. Then the third half-life, for the time the third half-life would be 1 times 10 power minus 5, right? So it's going to be the fourth half-life. Further, it's going to decrease by a half. So what's half of this? This is going to be, is it 5 times 10 power minus 6? Okay, every half-life, the concentration decreases by half. And that's the fifth half-life. So that's going to be 2.5 times 10 to the power minus 6. So it took how many half-lives? It took you 5 half-lives. Is that clear?
Yes, sir.
Or 5 half-lives. And what was one half-life? The time taken for one half-life. It's over here. It was 2.77 times 10 power 4 seconds. So 5. Every time the concentration decreases by a half, it took 2.77 times 10 to the power 4 seconds. So Kiara, what's the answer?
1.4 into 10 to the power 4.
That would have been
Sorry,
your
10
answer.
to the power 5.
Power 5?
Power 5. Yes.
3 significant figure hota, I think it's 1.38 then. So that's your answer, okay? There would have been a neat mathematical way of doing that, but that involves log. Okay? And some of you haven't done log, but that's so this is how you're going to do with log. That the starting concentration is 8 times 10 power minus 5, and into half to the power n. N is the number of half-lives. Every time it's going to decrease by half. First half-life, it's going to multiply by half. Second half-life, it's going to be multiplied by half 2 times, right? And the final answer should come out to be 2.5 times 10 power minus 6. That's your final concentration. So that's your formula. That you start off with your initial concentration, then how many half-lives, and then your final answer that you're looking for this concentration. So you take this to the other side. So 8 times 10 to the power minus 5. What do you get? What's the right? What's this right side? What's
0.03.25.
उसको अगर 1 over करो, 1 over divided by 0.0, is it 1 over 32?
Yes.
Okay, so this is basically 1 over 32. So you can kind of guess, okay, what's half to the power n? When would it become 1 over 32? That's going to be 5 times 2 to the power 5 is 32. Okay. Or अगर log में जाना, you would have to take log and then you have to figure out what n is. But you could figure that out directly as well. But is this clear? Well, ये question clear? Previous years didn't have these questions or similar questions. ठीक है, ये clear enough perfectly.
सर 1/32 के बाद आपने कैसे करना है?
अच्छा यहाँ पे वैसे तो अगर वैसे देखो ना तो खुद ही
जी,
सोचो ना,
आप
हाफ टू द पावर n है ना, तो n अगर 2 होता तो क्या होता 4, अगर 3 होता दैट वुड बी 8, 16, 32, 5 दफा n वुड बी 5, राइट? तो वो तो डायरेक्टली भी पता लग सकता है, ठीक है। द अदर वे इज यू टेक log, so it's log of 1 over 32 on both sides, and the log on the right side as well, that will become n log of half. Okay, calculator में क्या करना है? It's you have to find n. N is basically going to be log of 1 over 32, and that's going to get divided by log of half. Again, if you don't know log, it's all right. Okay, you can just stick with this method. Okay, your starting concentration is this. This is your final concentration. The half-life is constant. Every time you have one half-life, the concentration decreases by half. Okay, every half-life it decreases by half. So this method would be sufficient as well. Lekin clear है? Is this part clear? ठीक है, आगे मूव करें।
सर 5 हाफ लाइव्स हैं आंसर।
हाँ, ये देखो ना, 8 into 10 power minus 5 से start हुआ है ना, you have to end up कहाँ तक जाना है? The concentration should decrease to 2.5 times 10 power minus 6. Every half-life it decreases one half-life, first half-life. The concentration decreases by half, 4 हो गया. Second half-life, the concentration decreases by half again, 2 हो गया. Third half-life, concentration decreases by half, it becomes 1. Fourth half-life decreases by twice, but it decreases to half again, so it's going to become 5 times 10 power minus 6. Also, by the fifth half-life, it's going to decrease by the 5 half-lives. So 5 half-lives, the half-life value was given. Okay, what's the time taken for one half-life? And you got your total time. Clear बात?
जी सर।
अच्छा, अब आगे ये कि अच्छा, there's nitrogen monoxide reacts with ozone, NO3, NO2, and O2 are formed. The reaction is first order with respect to both NO and O3 at 298 Kelvins. The rate constant K is 11,500 K is given. First order with respect to both. It's first order with respect to both. Complete the rate equation. Rate equation would be K. It would be dependent on NO's concentration. Power is 1. The rate of reaction will be dependent on O3, and that power would also be 1. A reaction is carried out in which the initial concentration of NO and O3 are both this. Calculate the initial rate. So you just plug in the values. The value of K is given, that's 11,500. The concentration is given for NO, that's both of them are the same. So it's going to be 1.20 times 10 power minus 6 multiplied by the same thing, 1.20 times 10 power minus. So what is the rate of reaction you're getting? So 1.66 10 power minus 8. And remember, the unit for rate is always mole per dm cube per second. Now, the reaction in A2 is monitored over a period of time. Predict whether or not the graph NO against time under these conditions shows that the reaction has a constant half-life. Explain your answer. So, tell me, will it have a constant half-life or will it not have a constant half-life under these conditions? But what's the overall order of this reaction? The overall order in this case is 2. Okay, it's the rate is dependent on NO's concentration, power 1, and it is also dependent on O3's concentration, that's power 1 as well. So your overall reaction is order 2. दोनों को मिला लो ना, if you combine both of them, that's order 2. Now, if it's order 2, It can be order 1, but for that you would have to keep one of the concentrations to be constant. Like if I'm trying to investigate rate with respect to NO and I've managed to put O3 in excess, in a large excess, then the concentration of O3 will become constant. So it will not play any role because its concentration will not be changing. So in that case, I can say that the rate graph would actually be a first order graph because O3 is not playing any role. Like in this case, both NO and O3 have exactly the same concentration. So if NO decreases, O3 also decreases. So that means the rate will be affected by both of them. So it's going to be acting as an order 2 reaction. ये बात समझ आइए? Is that part clear? That its overall order under these conditions is going to be 2. Is that clear?
Yes, sir.
Or remember, if he had said that O3 was in excess, then I would have treated it, the rate graph, I would have treated it as a first order reaction because then only NO would be playing a part and NO's order is 1. Only this part would be affecting the rate. So predict whether or not the graph against under these conditions shows that the reaction has a constant half-life. No, it won't have a constant half-life because the combined order of both reactants, or the overall order, is 2. And in a second order reaction, the half-life doubles. So your successive half-lives in a second order reaction so the reaction would slow down very quickly. It's going to take a longer and longer time for the concentration to decrease by half. Because NO will decrease by half, the rate will slow down because it's order 1. O3 will also simultaneously decrease by half, and the reaction will further slow down. So that's why it's going to take a longer and longer time for the concentration to decrease by half. Agla part hai, at a high temperature, a small amount of platinum wire is added to a large amount of nitrous oxide. The reaction follows zero order kinetics. So a small amount of platinum wire is added to a large amount of nitrous oxide. The platinum wire behaves as a catalyst. Sketch a graph on the axis below of reaction rate against time for the catalyst decomposition of N2O under these conditions. So it is zero order, right? So that means when he says the reaction follows zero order kinetics, so I guess that means overall it's zero order. So that also indicates that overall the reaction rate, how does the rate of reaction change with respect to time for a zero order reaction? किस तरह का graph होगा? Is it going to be constant? Is it going to be, what would be the shape?
Straight line passing through origin.
Is that?
Yes.
This makes no sense. I mean, tell me rate of reaction, time t is equal to 0. Is the reaction faster at the beginning or slower at the beginning? When you're measuring rate of reaction of any experiment.
Faster.
So the rate of the reaction at time t is equal to 0 is not going to be 0. So the reaction will be fastest at the beginning. I mean, all reactions, they're faster at the beginning. And at a certain time, the rate of reaction will go to 0 because everything will get used up and the reaction will slow down. Now, since it's a zero order reaction, so will there be any effect on the rate as the reactant concentration decreases? कोई effect होगा? Like you have rate and your reactants are getting used up.
Slow reaction.
Zero order का क्या मतलब है? What does zero order mean? Is the rate dependent on the reactant concentration or not?
No, it's not.
So that means nothing will happen to the rate. So nothing would happen to the rate. So the reaction rate in this case, okay, it should go to zero, but it's not going to go to zero. It will abrupt to zero. It will just remain constant till the end. And all of a sudden, everything gets used up. So it will eventually go to zero because everything got used up. So it's not going to follow the same pattern that it will remain constant throughout. The reaction will not slow down. The rate of the reaction will be constant throughout the reaction. And then once everything gets used up, it's going to abruptly go to zero. Is this part clear?
Sir,
हाँ जी.
sir, वो straight line वाला इसका concentration time वाला graph था.
वो मैं दिखाता हूँ ग्राफ में दिखाता हूँ एक सेकंड. Let me discuss all the graphs. Just 1 second. कहाँ पे? ठीक है, इसमें ना difference. Make sure you know the difference between a concentration time graph and a rate versus time graph. तो यहाँ पे ना there must be. I mean, for example, this one. This is your rate graph. अच्छा, लेकिन this is not plotted with respect to time. ठीक है, this is plotted with respect to concentration. So in a zero order reaction, the rate just remains constant no matter what happens. So time को ना you can think of this as the concentration of the reactant, because with time the concentration of a reactant changes, but the rate will remain just constant. Nothing will affect the rate of reaction. Okay. The other graph that you have is where's the other graph? Well, half-life wala graph hai, okay? That's not this. So the other graphs are your half-life graphs. ये concentration time graph है, ठीक है? So concentration time graph, your concentration in a zero order reaction, the gradient is the rate, right? So we said that the rate is going to be constant, right? Which is why you got a straight line, constant straight line. So if you're plotting concentration, the change is going to be constant until the reaction finishes. In order one, the half-life would remain constant, so the reaction will slow down eventually because the rate will be dependent on the concentration of X. और जो order 2 है ना, उसमें the rate will be dependent too much on the concentration of X. So as the time proceeds, the reactant gets used up, but the time, every time it's going to take a longer time for the reaction to finish because it's going to slow down. ठीक है, तो ये आपके ना, these are your 5-6 graphs. ठीक है, you need to know how to plot them. But is this part clear that the rate is going to remain unaffected by the reactant concentration? ठीक है?
Yes, sir.
अच्छा, अगला part. Sketch the graph on the axis below of N2O constant. Now he's talking about concentration against time for this reaction. So N2O concentration. Now this is the concentration time graph. So remember, it's a zero order kinetics. So zero order kinetics, what's going to happen? Straight line. Okay, the reaction concentration will decrease, but at constant rate. The rate will not change. Okay, next one. Platinum behaves as a heterogeneous catalyst in this reaction. To describe the mode of action of a heterogeneous catalyst, how does a heterogeneous catalyst behave? 3 marks, you have to explain how heterogeneous catalysts work. How does it work? So the idea, what are the 2 steps in a heterogeneous catalyst? पिछला part clear है ना, ये graph वाला, is that clear?
Yes.
So heterogeneous, remember there are 2 types of catalysts. One is homogeneous. Homogeneous, you had to remember the iodine one. We already did that. You had to know the whole mechanism. For heterogeneous, it's this one. Adsorption and deadsorption. Somewhere over here must be mentioned. Take a second. Either notes me yoga start by, I think, catalyst. sorry, spinning catalyst. But I'll explain. Okay, I'll explain. In heterogeneous catalyst, the first thing that happens is, let's take the example of iron in the Haber process. यहाँ पे using for platinum, but let's describe iron for a second. What happens is that the first step is adsorption. What happens in adsorption is that when the reactant molecules, they come close to the catalyst starts attracting the electrons in the bonds, and the catalyst weakly bonds with them. That step is known as adsorption. So your catalyst forms weak bonds as it forms weak bonds with reactant molecules and adsorbs the reactant onto the surface. So this is the first step that happens, that so instead of the ends bonding to each other, the electrons, they get attracted to the catalyst. और उसके बाद क्या होता है कि the weak bonds break, and that's known as deadsorption. So your weak bonds break. So these bonds are going to eventually break, and the atoms would be free to move around, and they would be free to make new bonds. Now new bonds can be formed. So adsorption and deadsorption in heterogeneous catalyst. Suggest the reason why this reaction has zero order kinetics when the amount of nitrous oxide is large and the amount of platinum is small. So why is it going to have zero order kinetics? A small is added to a large amount of nitrous oxide. So क्या होता है excess के अंदर what happens? The concentration of nitrous oxide would be, so there was a reason why it was falling zero order kinetics, because when added in excess, N2O concentration would almost be constant. Okay, is this clear?
Yes.
Yes.
अच्छा अब अगला पार्ट, और एक सेकंड देना. अच्छा, the first one, identify the conjugate acid base pairs in reaction number 1. इसमें दो acid base pairs हैं. So what is this behaving as, this one? मेरी क्या behave कर रहा है? It's behaving as an acid.
Acid.
ठीक है, वो नीचे लिखते हैं ना. ठीक है, this is acid and this is its conjugate base. And what's the other one? The other one is your NAC is behaving as a base, and that is your conjugate acid. As a pair, he gave you. So now he has given you. A student investigates the rate of reaction number 2. Reaction number 2 concept, which one is this one. So there are two reactants, this one and this one. And he says the student mixes CH3CO -1 with large excess of NH3. So NH3 is constant in this case. So I guess you can measure the half-life for this one. What is the half-life? It's can't just start with the concentration like point. So that's kind of the first half-life. And what's the second half-life? Probably this one. So by just looking at it, the half-life is constant. So that kind of indicates that ye wala jo hai, the first one, that's order 1, because you have a constant half-life. अच्छा उसके बाद क्या है? Use a graph to show that the reaction is, I mean, we already showed that, we already did this. Explain why a large excess of NH3 is needed. So its concentration is constant. That's to keep its concentration constant. The next part here, the student measures the effect of changing the concentration of NH3. Now he's investigating NH3. So based on these two experiments, he did 2 experiments and he is changing the concentration of NH3. The first or second experiment, by what factor did he change the concentration of NH3? किस factor से change किया था?
1.5.
ठीक है, so it was changed by a factor of 1.5. By what factor did the rate change? Divide 2.21 by 1.47. Is that coming out to be 1.5 as well?
1.5.
वो भी 1.5 is that means it's order 1. ठीक है, it's directly proportional. So it is 1.5. So वो लिख देना कि experiment 1 and 2 you compared. The concentration of NH3 changed by 1.5 times and the rate also changed by 1.5 times, which is going to suggest that it's order. So that would suggest that it's order 1 as well. That's agla part. Describe the effect of increase in temperature of the rate of reaction, and you have to explain it as well. So ये तो आसान है. Temperature, what happens? You get more kinetic energy. Particles have more Ke kinetic energy. Because of more kinetic energy, they're going to travel faster. So you're going to get more frequent collisions or more collisions per unit time. And you would also get more successful collisions. They're going to be more effective because they would have more energy. So there will be more energetic collisions as well. Now, the next part is वो उससे organic से उसको छोड़ देते हैं. अच्छा, अगला part. अच्छा, now question number 3. He says that the iodates are compounds that contain IO3-1. Explain with reference to the qualitative model of electron pair repulsion why the IO3-1 ion has a pyramidal shape. The reason it has a pyramidal shape is that it's got 3 bonds. Iodine has 7 electrons in total in its outer shell. So how many bonds is it making? It's making 1 over here, 2 over here, 2 over here. So that's making 5 bonds. So if it's making 5 bonds, that means there's 1 lone pair left. Okay, there are 2 electrons that are still left. So iski jo shape hogi na, that's going to be pyramidal. The oxygens will be, and the lone pair would be sitting on top of it. Okay, is this clear? And the angle would be 107 degrees. तो आपने बता देना कि बस इसके अंदर the only thing, it's 1 mark. You just have to explain that it's got 1 lone pair and it's got 3 pairs of bonds or 3 bonding pairs, which is why it's going to be pyramidal. The reaction of iodine with hot aqueous NaOH is similar to that of chlorine and hot aqueous NaOH. So basically it's the same reaction as chlorine with AS. What happens if you react it with hot NaOH? It's going to form NaCl. It's going to form NaClO3 and it will form water. So Cl ki jagah just change it to I, that's it. So this one is a bit of electrochemistry in this. Use the data to show how the separate reactions of H2O2 and IO3. Use data to show that the separate reactions of H2O2 and with IO3 minus 1 and with I2 are both feasible under standard conditions. In your answer, give the equation for the reaction of H2O2 with I2. So you have to, I think, write two reactions, H2O2 with IO3 minus 1. So H2O2 is clearly the higher potential, so it's going to gain electrons. And IO3 minus 1 is the lower potential. So that is the one that's going to, I said, well, two H2O2s, and there's this H2O2. I said, we're going to do this equation first, H2O2 with IO3 minus 1. So H2O2 is turning, H2O2 is turning into O2. So it's this reaction. The lower potential loses electrons, turns into O2. And IO3 minus 1 turns into I2. So IO3 minus 1 over here turns into I2. So that gains electrons. So what is the E naught cell? How do you calculate the E naught cell? That's reduction potential minus oxidation potential. So reduction आपके पास है, that's 1.19. And the oxidation is 0.68. So you're getting a positive value, which is greater than 0. 0.51. So that's it. So this one is a feasible reaction. So this one is a feasible reaction. I said the other one, H2O2 with I2 as well. Okay, that's the first one. Okay, first one okay. The second one is H2O2 with I2. So you do everything again. First wale ko usne nahi mangi. He already gave you the equation. So that one is already done. Now H2O2 with I2. So you got H2O2, that's the higher potential. So that gains electrons. I2 is the lower potential. It loses electrons. So reduction minus oxidation, this one would be 1.77 minus 1.19. And again, you're going to get something that's positive potential. So that means the reaction is feasible and you can make an overall equation, 0.58, okay? And you can make an overall equation by adding the two. But before adding, you have to, I think, multiply the first equation by 5 and the second equation by 2 so that the electrons lost and gained are equal. So it's going to be 5H2O2. What's here? That's 10H plus 1. On the product side, you're going to have 10 H2Os. Okay, that's the first one. And the bottom one, it's going in the backward direction. So multiplied by 2. So that's 1I2 plus 3H2O. And in the backward direction, the products are going to be IO3 minus 1, 2 IO3 minus 1. Plus there's going to be 6H positive ions. So you're getting this thing. And anyways, both of them are positive potential. So, and then he says, write the overall equation for the decomposition of H2O2 catalyzed by IO3 minus 1. So I think it's an overall equation where what happens is that the first reaction and the second reaction, they need to be added up. So the first reaction and the second reaction, they need to be added up, and you can come up with this equation, the overall decomposition of H2O2 catalyzed by IO3 minus 1. So overall decomposition. So in दोनों को add कर लो. I think most of the IO3 minus 1 is going to get cancelled out. ठीक है, वहां पे भी I'm just going to add this up. इधर ही add कर लेते हैं. IO3 minus 1, you got IO3 minus 1, so that gets cancelled out. Who else gets cancelled out? I2 is in the reactants, I2 is in the products, that gets cancelled out. What else is getting cancelled out? You got 12, so add up kar lete hain, that's 10 H2O2s. And I've got 10 plus 2H plus 1, that's 12 H plus 1 ions. I got 3 H2Os as well. And in my product side, I've got 5 O2s. And I have Orchid product side where I've got 5 O2s, I've got 6 H2Os, 10 H2Os, so that's 16 H2Os. और हमारे पास है, we have 6H plus 1. So the H plus 1s are going to get cancelled out. 6. The waters would probably be cancelled out as well somewhat. So there'll be 13 left. पता नहीं if this is balanced or not. I just did this very quickly. So it's does this look balanced? 20 oxygens, that's 10. नहीं, ये balanced नहीं है. We probably did something wrong. I mean, is this equation fine? So the first equation was given already. So that's obviously balanced. The second equation, we made it up ourselves, H2O2 with I2. So I said that I2 loses electrons, H2O2 gains electrons. So it was 5 H2O2, 10 H plus 1, and 10 H2Os. And this going in the backward direction, that was I2 plus, it's 3 nahi hai, that's 6. The 3 over here is going to double. Okay, so this would actually be 6. And product you're going to have 2 IO3 minus 1s, that's there, and there's 16 H plus 1. Okay, so this one was 16 H plus 1 ions. So ये एक और मसला था. Now you can try and balance this. It's अब हो रहा है balance. It's 10 H plus 1, 16 H plus 1. तो इसको अब देख लेना कि बहुत ज़्यादा टाइम लग जाए इस पे. But let's just do this quickly. 5 H2O2. The 6 H2Os. And I've got 10 H2Os on the other side. I2 तो वैसे ही cancel out हो गया. अच्छा, वो सारे को add up करना था. अच्छा, ये confusion, एक second है ना. अच्छा, 5 H2Os, 5 H2O2s over here, that's 10 H2O2s. 2 H plus 1, 10 H plus 1, that's 12 H plus 1. Okay, that's still there. IO3 minus 1 gets cancelled out, that's gone. As a product side, where you've got why was it getting water over here? As I saw you, there's 6 water over here, so that's 6 water molecules as well. A product side, where you're going to have 5 O2s, or either product side where you're going to have 10 H2Os. And 16 हो जाएंगे. 10 पहले ही है, 6 ऊपर भी है. Just 1 second, mouse. I said I've got 16 H2Os and 16 H plus 1 ions. But इसको further simplify कर लो. It's probably going to get balanced out. इसमें मैंने बहुत ज़्यादा cutting कर दिया, so just add up these two equations. वो हो जाएगा ना खुद ही. But is this clear, this part?
Yes, sir.
So why didn't you use the 0.68 one, the half
What's that?
equation? Sir, आपने जो last half equation थी 0.68 वाली, आपने वो use क्यों नहीं की?
वही यूज किया. ऊपर वाली ना 0.68 वाली.
Yeah.
ये था ना, this was एक सेकंड, मेरा माउस पर कहाँ चला गया, एक सेकंड रुको. Just a second. ये था ना, this was the first equation and this was your second equation that we made up, right? ये थी और वो थी, that there were two equations, right? Let me highlight them. That was the first reaction, and that over here, this one over here was the second reaction, right? तो इन दोनों को ऐड करके ओवरऑल इक्वेशन बनानी थी ना, ओवरऑल इक्वेशन हमने वही किया, बस वो मैंने कटिंग इतनी कर ली है कि उसको थोड़ा सोच के आराम से ना वो कर लो कि व्हाट्स द ओवरऑल इक्वेशन. इज दैट क्लियर?
Okay.
अच्छा ये बोला, you're given a table with different concentrations, so you have to figure out the order with respect to H2O2 first. So concept, which experiments would you compare for H2O2?
Three and four.
Okay, you're going to compare, because only H2O2 should change, so 3 and 4. The concentration of H2O2, kya factor? That's 1.5 times it increases. So by what factor does the rate of the reaction change? So divide 8.82 by 5.88, and that would also be, I'm pretty sure that's going to be 1.5 as well. So that means directly proportional. So you're gonna state, okay, you're comparing which experiments 3 and experiment 4, और फिर वो बाकी बात बता दो कि the concentration of H2O2 changes by 1.5 times and the rate also changes by 1.5 times. Hence, the order with respect to this thing is going to be 1. Clear है बात? और इससे अगला जो part है ना वो ये कि IO3 minus 1. Which experiments would you compare for IO3 minus 1? Remember, pick those experiments where you keep everything else constant. Uh, 2 and 3, the H plus 1 is also changing concentration. So you can't investigate rate with respect to IO3 minus 1 because H plus 1 is also changing concentration. So 2 or 3 काम नहीं करेगा. Are there any experiments where IO3 minus 1 changes while the rest of the concentrations they remain constant?
No.
सर फर्स्ट और थर्ड कंपेयर कर सकते हैं क्योंकि हमें H2O2 का ऑर्डर पता है.
हाँ वो कर सकते हैं. तो उसके लिए what do you do? कि अच्छा, so the problem is कि there's no experiment where you can't, I mean there's no way you could investigate rate with respect to IO3 minus 1 because the other ones are also changing concentration. तो आप 1 और 3 को कर लो. अच्छा, reason 1 and 3 is कि you already know that H2O2 is order 1, so you know the partial rate equation. जो आपकी partial rate equation है, that's rate is what? K times H2O2 is order 1. You already know that. And IO3 minus 1 is what? Uska order nahi pata. That's X. And H plus 1 is also not known. Okay, that's why. You don't know 2 orders. So आप क्या करोगे? You just fill in the rate equation by using values from experiment number 1. If you do that, it's going to be, what is the rate? It's 1.47 times मैं experiment 1 की बात कर रहा हूँ, ठीक है? I'm plugging in values from experiment 1, 1.47 times 10 power minus 5. And that's equal to K times H2O2 concentration, which is what, 0.05. Okay, power 1. IO3 minus 1, that's 0.07. That's X. And H plus 1 is 0.025. And you don't know what the order is, 5. Y कर देते हैं. You plug in experiment number 2, not experiment number 2, experiment number 3. उसके अंदर the rate is 5.88 times 10 to the power minus 5 K, and it's 0.1 order 1. This is 0.14. That's X. और आखिरी वाला that's 0.025. That's why. Now there are two ways you can either solve the two simultaneously. What you can do is you can plug in the first k into the second. I mean, इसको subject of the equation now, the first k, make it the subject and plug that k into the second equation. Or you can, the other simpler way is you just divide the two equations. If you divide the two equations, the k's are going to get cancelled out. This part would get cancelled out. So what are you left with? You'll be left with a 10 power minus 5 would get cancelled out, right? So it's going to be 1.47 over 5.88 is equal to, I'm going to bring this to the other side, the numbers over here. So it's going to be 0.1 divided by 0.05. And 7 over 14, that's 1 over 2. So that's going to be 1 over 2 over x. What do you get for this? Here?
It's 1/2.
1/2, so that's 1/2, right? So that means x is 1, right? So with IO3, it's also 1. So remember this, if you can't find experiments where the concentration of only one is constant while the of the other reactants are constant and only one is changing, if you can't do that, you plug in the values into the rate equation and solve it simultaneously. Okay? So clear one आ गया. And then the only thing left is you can do the same thing, exact same thing for this one as well. इसके लिए कोई निकला है वैसे? Is there any experiment where this is changing and the others are constant? इसमें भी वही issue है कि the others. So you can plug in.
सर
हाँ जी.
सर ये जो हमने एक्सपेरिमेंट 1 और एक्सपेरिमेंट 3 को रेट इक्वेशन से किया सर, इसको हम डायरेक्टली भी तो कर सकते हैं, यानी
बस देख के?
रेट का पॉइंट देख के.
नहीं, वो टेबल को देख के कह रहे हो ना आप?
जी.
कर सकते हो. वर्किंग के कोई मार्क्स नहीं है, मतलब टोटल 3 मार्क का क्वेश्चन है, जस्ट 1 मार्क क्वेश्चन. तो ये जो वर्किंग की है ना, ये तो मैथमेटिकल जस्टिफिकेशन है कि वो 1 कहां से है. यू कुड हैव जस्ट लुक्ड एट इट कि 0.05 becomes 0.1, so it doubles, right? So आपको पता होगा 1.47 को double करो, it's going to become what is double of 1.47? That's going to be 2.94. 2.94 हो जाता. तो फिर यहाँ से आप देखते हैं कि then 7 is doubling also, so that means 2.94 is going to 5.88. So you could have, but that's harder to actually see. वो इस तरह कर लो ना, तो उसमें at least पक्का होगा कि this is your right answer क्योंकि you've mathematically solved it. ठीक है, is this clear?
Yes sir.
लेकिन इसके कोई marks नहीं, it's just a 1 mark question, that's it. Now order with respect to h+1, so final वो आखिरी को चलो directly कर लेते हैं. Let's try and do this directly. You know, let's compare 1 and 2, right? So this is order 1. Well, also you can do this one, like plug in experiment 1, plug in experiment number 2. Either substitute the k from the first to the second one, or just divide the two equations, and you'll figure this out. अच्छा, लेकिन directly ये double हुआ है, so you know it's order 1, right? So the rate doubles 1.47, it becomes 2.94. But this is also doubling, but there's no further doubling on the other side. So that means you order 0, and this is order 0. That means this has absolutely no effect on the rate of the reaction, because you know that it doubled because of this. You knew that this was order 1, right? But so that means the h+1 is playing absolutely no role whatsoever. If h+1 was order 1, then it would have doubled again, which it did not. ठीक है, तो ये clear है, आपके तरीके से करके डायरेक्ट कर लिया. Is that clear?
Yes sir.
So if you can write the rate equation, or and you can calculate the constant k as well by using experiment 4. So finally, okay, write the rate equation, once you have all the variables, you can just plug in data from experiment number 4 and you can find out K and also its units. अच्छा, और वैसे कोई देख लेते हैं इसमें, इस वाली वर्कशीट में कोई ये बस देख लेना कि लेटेस्ट जो है ना थोड़े से ना जस्ट स्लाइटली ट्रिकी है, ठीक है। तो बस फिर यहीं पे एंड करते हैं, ठीक है। कल फिर कंटिन्यू करेंगे। मुझे टॉपिक बता देना, we'll do questions on that topic then, ठीक है। अब थोड़ा टॉपिकल चलेंगे, ठीक है।
सर ऑर्गेनिक
बस ठीक है, ऑर्गेनिक के कर लेते हैं।
सर ऑर्गेनिक के करा दें, स्पेशली लास्ट वाले टॉपिक से।
ठीक है, ठीक है, मैं एक सेकंड में देख लूं कि एक से मैं पहले दिखा दूं कि शायद ये वाली, एक सेकंड। अच्छा, नाइट्रोजन कंपाउंड्स और एस्टर्स और पॉलीमर्स।
सर कार्बोक्सिलिक एसिड से शुरू कर लेते हैं।
बस ठीक है, वो ऑर्गेनिक का होगा कि अच्छा, इसमें ना मैंने जो ऑर्गेनिक है ना वो तो मैंने ऑर्गेनाइज ही डिफरेंट तरीके से की हुई है कि वो इलेक्ट्रोफिलिक सब्स्टिट्यूशन ना सारे इकट्ठे किए हुए हैं, हाइड्रोलिसिस सारे इकट्ठा किया हुआ है, एसिड बेसिस
सर आप
इकट्ठा किया।
अपने हिसाब से करवा लें।
बस ठीक है, तो वो मैंने तो वो थीम के हिसाब से ना कि वो कुछ क्वेश्चन सारे एसिड बेसिस पे आते हैं, सो दैट्स उसके अंदर कार्बोक्सिलिक एसिड, फिनोल्स, वो सारे आ जाते हैं, ठीक है। रीडॉक्स में जो क्वेश्चन आते हैं वो सारे मैंने इकट्ठे किए हुए हैं, ठीक है। तो फिर उस
सर ये
हिसाब से
कंप्लीट करा दें आप, ये वाली जो आप दिखा रहे हैं।
चलो ठीक है, ठीक है, चलो फिर कल करते हैं, ठीक है।
थैंक यू सर, अल्लाह हाफिज। सर उसका पीडीएफ सेंड कर दें जो आपने आज कराया।
फिर मैं करता हूँ। ओके, अल्लाह हाफिज।